Hi, pre-algebra students. These are your notes for 9.3 on two-way tables. So we have two big goals that we're going to be working on in this section, and that is to understand what a two-way table is and how to interpret the data. And then in the second half of our lesson today, we're going to learn how to make a two-way table based on some information that we've gathered in a survey. So we're going to start with some vocabulary. So this just explains what a two-way table is. So it just tells you that if you're collecting data, like let's say you go out and do a survey, you collect that data. Two-way tables just to organize that data so that you can make sense of it and understand what it means. This is probably new vocabulary. Each entry in the table is called a joint frequency. So you'll notice in the first example down here, you can see that they've identified the joint frequencies in the two-way table. So 21, 1, 2, and 6 are the four joint frequencies in the two-way table. And we call them joint frequencies because we're joining together two pieces of data to understand their meaning. So for example, in this first one, we want to know how many students in the survey studied for the test and passed the test. So you're looking for the joint frequency underneath studied and passed. So that's this number right here, the 21. So that's the answer to the question is 21 students. Okay, so for example, if I said how many students did not study and failed the test, that would be this number here, 6. 6 of those. Okay, we'll talk about that a little bit more as we move along. So in example 2, we're going to talk about finding marginal frequencies. Marginal frequencies are just the totals of the rows and the columns, okay? And you'll notice that I set this up before I created the video just because I wanted it to be constructed as neatly as possible on my tablet. So that's kind of tough to do. So you might want to use a ruler and get it organized so that it looks nice and neat. And so all we're doing here is really just adding the rows and adding the columns. So the total number of students that passed the test is 21 plus 2, which is 23. The total number of students that failed the test is 1 plus 6 or 7. So some of them studied, some of them did not study, but there's a total of 23 that passed and 7 that failed. Okay, same thing with your columns, just add those. So we have 21 plus 1 is 22, and 2 plus 6 is 8. And then the key here is that this number that goes right here in the corner, you want that number to total the same. When you add down and you add across, it has to add to exactly the same thing. So 21 plus 3 is 30, and 22 plus 8 is also 30. So you know that you have totaled all of those numbers correctly and your marginal frequencies are correct. Okay, so go ahead and complete the on your owns. And I'm just going to remind you down here, let's see, this has changed a little bit. How many students find and interpret? No. So I want to remind you on part B, when you find and interpret the marginal frequencies, please note that you have two things. So you not only want to identify what the marginal frequencies are, and you can draw them in the table if you want, but interpret them means explain them. So you need to write an answer for that part of the question. We'll go over that tomorrow. Okay, so moving on, this time again, now we're making a two-way table. So this is kind of the second part. And again, you'll notice I did this before I started the video because it takes a little while to get this all nice and neat. So I put the ages. I just took this. We randomly surveyed students between 12 to 17 to see if they ride the bus or don't ride the bus. And we have two tally sheets of data to put in our table. And notice it says we want to include marginal frequencies. So I already made a spot on here for our totals as well. So I'm going to use this information. And again, I've already created this. So if you need to pause the video and create your table, please do that now. Otherwise, I'm going to go ahead and explain where our numbers come from. Okay, so there are 5, 10, 15, 24 students between the ages of 12 and 13 who ride the bus. So that number goes here. There are 5, 10, 12 students between 14 and 15 who ride the bus, and there are 5, 10, 14 students between the ages of 16 and 17 who ride the bus. I'm going to do the same thing to find out the number of students who do not ride the bus. Just tally those up, 5, 10, 15, 16, 5, 10, 11, 12, 13, and 5, 10, 15, 21 students do not ride the bus between 16 and 17. Okay, so you either can use mental math here or go ahead and grab your calculator, and remember to find our marginal frequencies. We're going to find the total of each row and find the total of each column. So if you add 24 and 16, you get 40. If you add 12 and 13, you get 25. 14 and 21 gives you 35. And then I'm going to do the same thing for my columns. So if I add 24, 12, and 14, I get 50. And then 16 plus 13 plus 21 also gives me 50. 50 and 50 is super easy to add. That gives me 100. And then if you take your calculator, or again, just check it using mental math, remember the sum of all of those numbers in this column should also total 100. So that means there were 100 students overall that were surveyed or who participated in the survey. Out of those, 50 students said they rode the bus, 50 students do not ride the bus. And then there were 40 students in the survey who were between the ages of 12 and 13. 25 students in the survey were between the ages of 14 and 15, and 35 students in the survey were between the ages of 16 and 17. Okay, so that's just a little more information on how to interpret that data or information in the table. Okay, so for this one, I actually have not created my table yet, so I'm going to pause and do that real quick. All right, so this is not my neatest work. So again, you may want to use a ruler just to kind of organize this, but you can see I'm going to have the same information, the ages on the side, and either ride the bus or do not ride the bus. So here are the ideas. We're calculating percent, and percent is always a portion out of the total. So that's why you have to have those marginal frequencies, so you know the total number of students that participated. So the first thing I'm going to do is write a ratio. So of the 12 to 13-year-olds, sorry about that, 24 of them out of a total of 40 ride the bus. Okay, I'm going to go to how many of those do not ride the bus. So there were 16 out of 40 who do not ride the bus. I'm going to do the same thing for the other rows. So in the 14 to 15-year-olds, there were 12 out of 25 who ride the bus. And there were 13 out of 25, whoops, that was here, 13 out of 25 not ride the bus. For 16 to 17-year-olds, there are, see, 14 out of 35 who do ride the bus, and 21 out of 35 do not ride the bus. So the next thing you need to do is take your calculator and you need to change those fractions to percent. So this is just something you did before. So remember, fraction bar tells us to divide. So in my calculator, I'm going to do 24 divided by 40, and I'm going to round that to the nearest percent. So like 24 divided by 40 is probably giving you something like 0.60, and then you swoop and move that over. So this one, and you might have to round on these. You're just going to go to the nearest percent. So this one is about 60. Okay, I want you to practice pausing the video and calculating these, but I'm going to go ahead and put them in. So if you need to calculate, do that now. Okay, here are the rest of the answers. 16 out of 40 is about 40%. Oops. Okay, 12 out of 25 is about 48%. 13 out of 25 is about 52%. And then for 16 to 17-year-olds, 14 out of 35 is about 40%, and 21 out of 35 is about 60%. Okay, and what you should be noticing is that all of these percentages, if you add like 60 and 40, it adds up to 100%. They should all add up to 100 because that means the whole thing. Out of 100 is the total. Okay, so it says, does the table in part A show a relationship between the age and whether or not the students ride the bus to school? And I would say, yes, shows a relationship. shows that as the ages increase, students are less likely to ride the bus. Okay, so, and why is that? Probably you all could have predicted this already. As you get older, you're too cool for school and you can't ride the school bus, or maybe those 16 to 17-year-olds are now driving instead of riding the bus. So that makes sense in the context of this real life problem. Okay, please go ahead and pause the video or actually stop the video. We're finished with everything and you're going to do the on your owns on the next table. Please construct your two-way tables neatly and show your work where you need to, and bring any questions you have to class with you tomorrow. Have a good night.